So what information are we looking for here? In this question type, you'll encounter 3 sets of 3 numbers. So let's look at the example and see what they're talking about here. So there are 3 sets, so I see the 3 sets right here. And each set has 3 numbers, so I can see the 3 numbers here. And I can also see this one is missing a number. But that seems to make sense so far. And 1 number is absent from the 3rd set. Yep, we've already gone over that. The middle number in each group is determined by the outer numbers. Okay, so that's a lot of information already, so let's just break that down. So the middle number of each group, so it's talking about this number and also this number, is determined by the 2 outer numbers. Okay, so outer numbers. So what do they mean by the outer numbers? It's this one. So these are the ones of the outer ones, and this is the middle one. So what it's saying is these outer 2 numbers are determining what's inside. So this is basically just a result of 2 and 6. So what does it say about it? It says through a specific method. Okay, so basically we don't know what's happening to the 2 and 6, but something's happening to them that's making it into 12. All the groups follow the same pattern, meaning whatever they used to make 2 and 6 into 12, it's going to be the same thing for these ones. And your task is to identify the missing number of the 3rd set. So you can assume what you're going to do is you're going to find out how they got 12 from 2 and 6, how they got 20 from 5 and 4, and then you're basically just going to have to do the same thing to figure out the missing number. So your challenge is to discern the underlying pattern governing the relationship between the 2 outer numbers and the mysterious middle number within each group. So basically, you just have to figure out the relationship between the 2 outer numbers and the mysterious middle number. But yeah, hopefully that makes sense. I think most of you might have already spotted here what this is asking us to do. Or like how we got from 2 and 6 to 12. Most of you will be able to tell that this is just 2 times 6, so that's how we got 12. And then 5 times 4 gave us 20, so it's going to be 3 times 9, which is going to give us 27. So there you go, that's our answer, and now you can actually look down here as well, that it's 27. And as you'll know, it doesn't always have to be multiplication. It doesn't mean that 2 times 6 is it's always going to be the left times the right. It could be anything. It could be division, it could be timesing and then adding something as well. It could be, it could really be any sort of rule. So some of these can get very difficult and they can be very complicated, so we want to be careful with these and take our time, which is why we want to be fast on the other question types, and we can spend more time on these ones because they're definitely a lot more difficult. Right, let's go on to the practice now section, and straight away we're going to just look at the first section so you see what might be causing 4 and 5 to turn into 21. Immediately what I think is, it's 4 times 5 and then they added the 1, so it'll be 20 and then they just added the 1. Right, and then we have to see if this matches, if this works for this one as well. So if we try 17 times 3, that gives us 51, and if we add a 1 to that, that'll give us 52. So we know that the rule I came up with just there actually works on both of these, so we can apply it to here, meaning we're going to have to do 18 times 5. So if we just do that right here, it's going to be 40 and then 9, 90, and then we have to add 1 to it, so it's going to be 91. And there we go, that's our first question done. So let's do question 2. 8 and 9, how did it turn into 90? Alright, what I'm thinking again is maybe 8 times 9 will give us 72, and then you add the first number back on. So it'd be 72 add 8, right? So let's see if that works here. So if we do 11 times 5, that's going to give us 55. If we add 11 to that, that's going to give us 66. So that can't be the rule. That means we have to look for something else. 12 and 6. Okay. Alright, so what you can see here is, hold on, this is the wrong way around. But what you can see is actually these two numbers that I'm making it up are very similar to this. So 5 and 6, 11 and 12. Right, so all of these seem to just be one bigger than the other one. So what it seems to be doing is adding one to the left and adding one to the right and then timesing them together. So what this is probably going to be is going to be 10 times 10, which is going to give us 100. Now that's a really complicated rule. But yeah, these are the type of difficult questions that you can come up with, and the more rules that you've seen, the more prepared you'll be for these types of questions. So now this is something that you can try in the future, right? If you're stuck with all of these other rule types, you can try the +1 and timesing, because that could definitely be used, right? So let's go ahead and do question 3 now. So 70. What can we get to make 70? What I'm thinking is 7 and 10 make 70, right? So what might be happening here is 5 times 2, and then this is obviously kept the same, and then they're multiplied. So let's just have a look at that. If we do this times 2, yeah, so this seems to be working. So 3 times 2, that'll give us 6. We obviously keep the 10 the same, and then we multiply it. And once the rulers fit both of them, that means we can just apply it to here. So what we're going to do is times it by 2. It's going to give us 12, and we just have to do 8 times 12, and that will give us 90. So question 4, how do we get to 12 from 4 and 5? So what I'm going to give a shot. Okay, yeah, so let's try that again. Instead of doing 6 and 2, we'll do 4 and 3. And there we go, now we've got that. So 5 is turned to 4. So very similar to question 2. 5 is turned to 4, 4 is turned to 3, and you just multiply them together. So see if this works on this one. So 16 and 2, there we go, yeah, perfect. So this is going to be 5 and 4, and we're going to multiply it. That's going to give us 20. And there you go, and that's our answer for question 4. So let's move on to question 5. So again, these questions take a lot longer. That's why you want to be able to free up time by doing well on the other ones and doing them really quickly. So question 5, let's see this. What I'm thinking is we want to see if the surrounding numbers, for example 14 and 4, or the other ones, can actually make up 72. I don't know off the bat of my head if I'm actually able to do that. So either 14 and 4 or 12 and 6. Hold on, let me have a quick look at 12 and 6. I think that seems to make a bit more sense. So, oh yeah, there we go, 12 and 6. Yeah, that's going to work. So what's happening here is it's 12 and 6. So that's -1 plus 1. And this one is going to be -1 plus 1. So 6 and 7. Alright, okay, so that took a long time. But again, it's the exact same thing that's happening up here. But what they're doing is they're minusing 1 on the left to get 12, plussing 1 on the right to get 6, and then they're multiplying 12 and 6 together. And they're doing the same thing here. Meaning this is going to be 11 minus 1, which is going to be 10. And this is going to be 10 as well. Oh, so that's going to give us 100. I think this one was 100 as well, actually. But yeah, there we go. So that's our question 5 done. Right, you can see this very quickly. 3 and 3 on both sides. Very weird. And then having 27 in the middle. It will usually mean something like... I mean, you can see 3 is 23 is a multiple of 27. 27 is a multiple of 3, sorry. So it's going to be something to do with multiplication or indices. And actually, if you do 3 to the power of 3, you're going to get 27. So if you do 3 times 3, that gives you 9. And then you times that by 3 as well, that gives you 27. So there you go, you got 27 here. And then 2 to the power of 3, that's going to give you 8. So you can work that out yourself. That means we have to do 3 to the power of 5. So this one's actually going to be pretty big. Basically, it's just going to be 27 times 3, and you're going to have to times that by 3 again as well. So we'll work that out. Actually, I'll just calculate it and give you the answer, because there's no point in you watching me doing long multiplication. So that gives you 243, and obviously in the exam you'll have to just do long multiplication, you'll be able to get there. Question 7. So if we look at this, and if we minus 5 from the 14, it will give us 9, and then maybe if we times that, we'll get the answer. So let's see if we can do that. Alright, perfect. Actually, that was the first guess. Alright, 14, and then if you times that by 2, you'll get 28. So again, keep this one in your pocket. This is a very useful one that could come up, where you're basically just minusing this from this, and then you can probably find some sort of relationship there. So what I'm going to do here is obviously 5 minus 29, which gives us 24, and then we times that by 2, and that gives us 48. So that's the answer to this one. Question 8. Maybe if we double the 7. Alright. And what about if we double this? 28. Oh, okay, there we go, I see it. If we minus the 5 from the 28, you get 23, and if you minus the 3 from the 14, you get 11. There you go. So what we're doing here is doubling it to get 44, and then minusing the 21 from that, which will give us 23. Nice. Question 8. Let's carry on. Last few. Okay, so 5 times 4 is not it, but actually 5 times 8 does give you 60. No, it doesn't. No. 8 times something times something. 5 times 12 gives you 60. Okay, so this is times 3. So if we times this by 3, that gives you 21. If we times that by 4, I think I might have got this one actually as well. So let's see. 4, 2 times, and then 8. Oh, perfect. Right. So what we're doing here is we're timesing it by 3, which gives you 18. And then you're timesing 2 by 18, basically. So that will be 36. 36. There we go. Okay, cool. And that's question 9. And as you can see, actually, the more you do these, the more familiar you become with these sort of different patterns, and these are probably going to keep coming up, these sort of rules. And what I'd actually recommend is do these in pencil, pretty much all of the book in pencil actually, but specifically this section, do it in pencil, and then rub it out, and then come back to it and try it again within 2 or 3 days, and I'll guarantee you will have forgotten most of the rules by then. And so when you're retrying them, you're going to sort of be reinforcing these rules once you sort of figure them out. And you can actually write these rules out as well. So these are the ones up here, definitely. The one where you're minusing, what was it? You're adding 1 to both sides and then timesing it. Like, this is something that could definitely come up often. There was quite a few that was -1 +1 and then timesing it, and there was a few that was like -1 and timesing it. Like, these are all different things that you can write down and make sure that you have in your arsenal for the exam. Basically, in the case where you're stuck on a question and you don't know what to do, you can try a few of these out. If we times 7 by 2, that gives us 14. That's not giving us any leads, because this is already 18, right? What you want to do is perform as many different operations on these numbers as you can, and then usually at some point you will have created some number, like we did up here, where we created, I think we created 14. That sort of gives you a link between these two numbers. Here was actually 12. That gave us a link between these two numbers. So that's what we're looking for when we're doing a rule. Is you want to basically come up with some number that will give you a link. So if we times this one by 3 to get 15, and we add the 7, there we go. That's going to be it. So our rule is to times it by 3 and then add the 4, which is going to give you 25. Okay, and that's going to be our answer. Final one, question 8. Let's have a look at this. So 5 times 8 is going to be 40, and if we minus 1 that gives us that, but I doubt it's going to be that. So 7 times 3 is 21. Doesn't seem to be working. Alright, so let's have a look at what other numbers we could work with. We just try and square these numbers, square all of these numbers, see what that gives us. 64, 25, 49, and 9. Okay, I see a correlation here, so it might just be 9 minus 49. Let's have a look at this. So that's going to give you 59 and 39. Okay, so that's going to be our answer. So what's going to be happening here is we're going to have to square both of these sides and then figure out, and then just minus them. So I'm going to have to figure out what this is. So 5 times 1 is, it's going to give you 7. 1 times 5 is 5, and 1 times 1 is 2. If you add that up, 9, and that shouldn't be right. I have to double check that. Alright. I don't know what I did wrong there. Anyway, it's... Oh, I just haven't done the section. So, when you square that, you get 2 to 5. And then we have to minus them, so that gives you 200, sorry. And that's it, that's everything. So if you want to go over that video again, look at all of these different rules that we've used. It'll probably help you on that second section down here. You're practicing that next section. All of these different rules are quite useful. So what we're doing here is just squaring them and minusing them. Up here, what were we doing here? We were timesing this by 3. Yeah. Somewhere around here we were like adding and minusing, and there's loads of different stuff that we could be doing. So these are very useful rules to know, and these are the ones that you sort of want to reuse throughout it. And obviously don't use it as a crutch. Be able to perform operations on both numbers until you can figure out something that links them together. But like I said at the start, what you want to be doing is you want to do something to both numbers, or at least to one number. Do something to both numbers, and once you get like that result, you'll sort of figure out how that links these two together. Especially when it's not as simple as just multiplying them together. It'll be multiple operations. You want to be performing the first operation at least, and then figuring out from there.